Hi everybody and welcome to this new video. In the last months I have published a series of articles and videos about creating a real-time multiplayer game with Unity 3D and Amazon GameLift. The feedback I received about them had been outstanding. A lot of developers downloaded my source code and made their own project and games using Amazon services. I also received many messages and emails asking me for help. In this video I will explore the common errors people have experienced and how to troubleshoot them. In this video I will also share my knowledge about how to debug a GameLift game server. Let's go! This is the architecture of a real-time multiplayer game that I always suggest in my videos and articles. It contains three main Amazon services: Lambda, Cognito and GameLift. The Unity client invokes the Lambda function and retrieves credentials from GameLift in order to connect to the game server. Those are 5 common mistakes related to the architecture I could summarize. First of all, the AWS SDK for .NET. Many people asking me for help had trouble invoking the Lambda function from Unity. Remember that Unity uses .NET Standard 2.1 and the Amazon documentation recommends downloading the AWS SDK for .NET here for Unity. If you download the wrong version or download it from elsewhere, some Amazon services won't work correctly, including the Lambda calls. Then the Unity desktop clients. In my code I have included a mechanism to avoid consuming the game server resources if the users minimize the application. Some of you were trying to launch multiple Unity desktop clients and experienced server disconnections in the out-of-focus client. If you want to work with multiple Unity desktop clients, go to the app controller class of my project and comment the function onApplicationFocus and onApplicationPause. You can also add a conditional compilation for the Unity editor. Now about the connection between Unity and the game server. A guy sent me a message telling me that everything okay with the architecture, the Lambda function was called successfully, there were no errors in GameLift and the game sessions were created correctly. However, the Unity client was unable to connect to the game server. It turned out that he had a firewall installed on his local machine that was blocking most of the inbound and outbound connections. Remember that the connection between Unity and the GameLift game server is established thanks to the TCP and UDP networking. Therefore, ensure you don't have any software or systems that could block your TCP and UDP ports, like a proxy, firewall, VPN, etc. Okay, let's talk about the memory provisioning for Lambda. I have been told that for the first connection after a long time, more than 1 hour, to the Lambda function, a timeout error is returned and the player cannot join the game. This is totally normal. This phenomenon is known as a call start. A Lambda function has a default timeout of 3 seconds and returns an error if the execution time exceeds the function timeout. To solve this slow invocation issue, you have 2 options. Increase the function timeout or increase the function memory. Amazon highly recommends over-provisioning your Lambda function memory instead of the timeout to avoid unexpected costs. Finally, the GameLift launch path. Before creating your GameLift fleet, you need first to upload to GameLift a zip file containing your real-time script and dependencies. During the fleet creation, you will be asked for the launch path. In other words, the path of your JavaScript code file within the zip file. If you have compressed the JavaScript file directly, the path will be, for example, file.js. troubleshoot.js. If you have compressed a folder containing your JavaScript file, the path will be, for example, folder/file.js. Now suppose that your Unity client runs great and your Lambda function is invoked correctly, but a new game session cannot be created, probably due to an error in GameLift. The first thing you must check is whether your game server is running correctly thanks to the GameLift event and metrics. Go to the GameLift console, click on your fleet and go to the event section. This section collects all the log entries describing an event that involves GameLift resources. This can be helpful for troubleshooting and debugging problems. If your fleet is running correctly, you should see the following main events showing up in this specific order: fleet created, fleet state validating, fleet state activating, fleet state active, and fleet scaling event. If you see critical messaging during the fleet creation, something may be wrong with either the launch path we have seen previously or your real-time script. It may be a wrong syntax or a broken dependency. If you want to know more about how the real-time script works, please refer to my previous video. The last message of a successful fleet creation is a scaling message, meaning that your fleet has automatically scaled up, launching a new EC2 instance. If you go to the metrics section, you can visualize it, and your game server is running correctly. Now suppose that your game server is running correctly. Your fleet has scaled up, there are no critical messages in the event section, you are able to execute multiple Unity clients at the same time, and the multiplayer feature works great. However, in some cases your game server does not have the expected behavior and can even crash. In this case, something is failing in your real-time script and you want to check the value of specific variables at a precise moment of time. There is a simple workaround. You can write into the game session logs and then access those logs to see what happened. From my last video, I built a real-time multiplayer game that includes interactions with NPCs. I will add a few lines of code in the real-time script. When a player starts to talk with an NPC, I will write information into the game session logs. According to the GameLift documentation, there are 6 levels of server log messages. Let's try with 3 of them: info, warning, and error. We have written into the game session logs, now let's access them. This part is a little bit tricky. When a game session finishes, the related logs are stored in a S3 bucket. There is no simple way to access those logs. The only way to achieve it is by using the getGameSessionLog URL API call to get the location of the logs. I will implement the API call in a very simple way with a Lambda function. I'm a Python guy, so I will do it with Python, but it's up to you to choose your favorite programming language. Let's check the documentation of the official AWS SDK for Python Boto 3. We can figure out that the function requires a parameter called GameSessionID, described as a unique identifier for the game session to get logs for. But hold on, there is a slight confusion with the Boto 3 documentation and more generally with the whole Amazon documentation. We need the game session ARN, not the game session ID. Go to the GameLift console. In the game session section, you can find here the ARN of the terminated game sessions. Let's go now to Lambda. We create a new function and we call the getGameSessionLog URL function, indicating here the ARN of the game session we want to check. We execute the function. and we receive a pre-signed URL of the game session logs, which is basically a temporary URL valid for 15 minutes. We visit the URL and download the logs. I will unzip the compressed file and open the log file. The messages we write in the real-time script are here. We can see the 3 levels of log messages. This is a very basic example. As well, we could write values of specific variables or information about the server, and this could help us troubleshoot our GameLift game server. And that's it. Thanks for watching this video until the end. I really hope it helped you debug your real-time multiplayer game and understand more deeply how the game session logs work. If you have any feedback or question, feel free to reach out to me on my social network. See you in the next video.